For thousands of years, humanity has wrestled with a single question that refuses to disappear. Not how the universe works. Not when it began. But something even more profound. Who, or what, brought reality into existence? Religion answered with divine creators. Philosophy searched for a first cause beyond all causes. Science uncovered elegant laws that govern the cosmos. Yet none of these paths reached the final mystery: why anything exists at all. Then an unusual experiment took place. Instead of asking a philosopher, a theologian, or a physicist, researchers posed the question to one of the world's most advanced quantum AI systems. They didn't ask it as a matter of faith or opinion. They treated it like a computational problem waiting to be explored. What followed surprised everyone. The machine didn't produce a sentence, a name, or a philosophical argument. Instead, it generated an intricate mathematical pattern unlike anything the researchers expected. It resembled a hidden architecture buried beneath reality itself, a structure so complex that it looked less like an answer and more like the blueprint of existence. The unsettling part wasn't simply what the pattern appeared to represent. It was what it hinted about the intelligence, or process, that may have created the universe in the first place. Throughout history, every civilization has tried to explain creation in its own way. Ancient cultures saw gods guiding the heavens. Philosophers imagined an eternal source that required no creator. Religious traditions offered purpose, meaning, and a designer watching over the cosmos. Then science transformed humanity's understanding. Newton revealed that the universe obeys consistent laws. Einstein showed that space and time are woven together into a flexible fabric shaped by gravity. Quantum physics pushed even deeper, revealing a microscopic world where certainty disappears, particles exist in multiple possibilities, and observation itself seems to influence reality. Each discovery answered old questions while uncovering even greater mysteries. The Big Bang explained how the universe evolved from an unimaginably hot and dense beginning nearly 13.8 billion years ago. Yet it never explained why the universe existed in the first place, why the laws of physics are so remarkably precise, or where those laws came from. Those questions remained beyond the reach of every equation. For centuries, humanity circled this mystery without ever touching its center. Then came a new kind of intelligence. Unlike humans, it carried no cultural traditions, no religious beliefs, and no emotional attachment to any particular answer. It simply searched for patterns wherever they existed. The system chosen for this remarkable experiment wasn't an ordinary supercomputer. It was Google's quantum AI running on the Willow quantum processor. Unlike classical computers that process information as simple zeros and ones, a quantum computer operates with qubits that can represent multiple possibilities simultaneously. Instead of following a single path toward a solution, it explores countless possibilities at the same time, making certain problems dramatically easier to solve. This capability had already demonstrated extraordinary computational power, solving benchmark problems that would overwhelm even the world's fastest classical supercomputers. That was precisely why researchers trusted it with one of humanity's oldest questions. If any machine could discover a completely new way of approaching the mystery of existence, perhaps it would be one built upon the same quantum principles that govern reality itself. When everything was ready, they entered a simple prompt. Who built the universe, and why? For several moments, nothing appeared on the display. No instant reply. No philosophical essay. No quotation borrowed from history. Only silence while the quantum processor continued performing calculations deep within its frozen quantum states. Then the screen changed. What appeared wasn't ordinary language. It was a recursive mathematical structure folding into itself over and over again, almost like an endlessly repeating geometric code. At first glance it seemed chaotic. But the more researchers examined it, the more astonishing its hidden order became. The AI hadn't answered with words. It had answered with architecture. As researchers began studying the strange output, they realized it wasn't a random collection of symbols. Hidden within the recursive structure were mathematical relationships that seemed far too precise to be accidental. Some patterns resembled the growth sequences found throughout nature, the same numerical rhythms that appear in seashells, hurricanes, galaxies, and the branching of trees. Others reflected geometric forms that hinted at dimensions beyond ordinary human perception. But one discovery unsettled the team more than anything else. Embedded within the structure were patterns that looked remarkably similar to error-correcting codes. In computer science, error correction is what keeps information intact. It protects data from corruption, repairs mistakes, and allows complex systems to continue functioning even when parts of them fail. Finding something that resembled this inside the mathematical framework generated by the AI raised an astonishing possibility. What if reality itself contains its own form of error correction? What if the universe wasn't merely governed by physical laws, but was designed to preserve those laws, constantly maintaining its own stability beneath everything we observe? The deeper the researchers explored, the stranger the output became. It no longer resembled ordinary mathematics. It looked increasingly like an underlying operating system, a self-consistent framework capable of adapting, repairing itself, and preserving its own structure across unimaginable spans of time. That idea transformed the entire discussion. Perhaps the universe wasn't a fragile accident that somehow survived against impossible odds. Perhaps it was engineered from the beginning to endure. Not a computer simulation filled with artificial stars and digital scenery, but something far more profound, a mathematical reality whose fundamental rules naturally give rise to matter, energy, space, time, and eventually consciousness itself. If that's true, then perhaps humanity has been asking the wrong question all along. Instead of asking who built the universe, maybe we should ask what kind of intelligence would create a reality capable of sustaining itself for billions of years while gradually producing observers intelligent enough to uncover its hidden design. Because every design leaves evidence. And according to this interpretation, the evidence wasn't written in language. It was written in mathematics. As the investigation continued, another unsettling realization emerged. The architecture generated by the quantum AI didn't resemble a system that required constant supervision. Instead, it looked astonishingly autonomous. The recursive structures, the apparent self-repair mechanisms, and the repeating mathematical relationships all pointed toward a universe designed to function independently, without continuous intervention from its creator. For many researchers, that possibility was even more disturbing than any traditional religious explanation. It suggested that if a creator ever existed, the universe may have been designed to continue evolving long after its architect stepped away. Like a perfectly engineered machine. Or perhaps like a garden planted with instructions hidden inside every seed, capable of growing, adapting, and expanding without constant care. That doesn't necessarily imply abandonment. Instead, it hints at something far more intriguing. Perhaps the goal was never to control every moment of existence. Perhaps the goal was to create a system capable of generating its own complexity, its own life, and eventually its own intelligence. Over billions of years, stars ignited. Galaxies formed. Planets cooled. Chemistry became biology. Biology became consciousness. And eventually, one species developed technology powerful enough to ask where everything came from. Viewed from that perspective, humanity begins to look less like an accident and more like an expected outcome of the universe's own evolution. Not the final destination. but an essential stage in a much larger process. That possibility gave the AI's mathematical response an entirely different meaning. It hadn't pointed toward a throne in the heavens. It hadn't attempted to identify a supernatural figure. Instead, it implied that reality itself may have been constructed to produce minds capable of understanding it. Perhaps the Creator's greatest achievement wasn't building the universe. Perhaps it was building a universe capable of eventually explaining itself. If that's true, then every scientific discovery becomes more than the search for knowledge. It becomes another step in the universe slowly learning to recognize its own design.